So, welcome back. We have started looking at this family of logics called description logics, and we have seen that basically we are allowed to talk about concepts and relation between concepts and relations between relations and relations between individuals and concepts. So, the key feature of description logic is that you are allowed to create new concepts using concept constructors. So, let us look at some of them. So, concept constructors allow you to create new concepts from existing concepts. So, you can start off with a set of basic concepts. We did that when we were defining the family database. We said that we will talk about only two kinds of relations. One is a parent child relationship and the other is a gender relationship. So, using only these kind of facts, what is the gender of a person and how are two persons related, we will construct the rest of the knowledge base. So, we will define aunts and uncles and grandfathers and ancestors and so on. Let us see how we do that in description logics, and we will see the various ways in which this can be done. So, what are concepts? Concepts, we will use the term symbols C and D to stand for concepts, and they can be any one of these that is listed on the right hand side of the arrow essentially. We will look at them one by one. So, the first one in that list is the top concept. It is also called thing in OWL. And everything in the domain is members of the top concept. So, it basically defines the whole domain. Everything is included in the top concept, all elements. The second one is called the bottom concept. It is also called nothing in OWL. It stands for the empty concept or the empty set essentially. There is nothing, there is no element which belongs to this concept. The empty concept is the bottom concept. Then we have named concepts, where a name A comes from the set of names that we have defined for concepts essentially. And a name concept is essentially the interpretation of that is that it is a subset of the top concept. So, if this is a top concept, this thing, then we have a concept A, and so all the elements which are in this A, it defines a subset of the elements of this thing. That was a named concept essentially. So, name concepts are like primitives essentially, right. For example, we might say male, female or something like that. Then the complement or negation. So, in the description logic, the symbol for negation basically stands for complement essentially. And the interpretation of complement, as you can imagine, is that if you have some concept, let us call it C, then everything that is not in C is in the complement of C. We are always drawing our Venn diagrams with the top concept as the domain essentially. Then intersection. Members of concept C are also members of concept D essentially. So, if you have a concept C here, if you have a concept D here, and this is your top concept, this is C, this is D, then all this is elementary set theory. It is just that we are using a language to define and name those sets. So, if you give us two sets, this thing which stands for two concepts. For example, uncles, set of uncles, the set of gentlemen. You can define a set of uncles who are gentlemen. There was a nice novel I read from P.G. Woodhouse which said aunts aren't gentlemen. So, clearly that would be a true statement, but uncles can be. This other symbol stands for union. So, if you have C, if you have D, then everything which is in either of them is in the union of the two sets. Notice that the two sets can still have an overlap. Then we have this restrictions on roles. So, R stands for a role and C is a concept. So, this for all C says that all those objects whose role is filled with members only from the concept C essentially. So, first we have something called a concept C, and now we are trying to define this new concept whose all role fillers come from the class C, which basically mean that if I have this element here and it is related to another element here and it is related to another element here, then I can put it in this class for all C. See, this class we have not given it a name, but we have given a description of the class. This class that I am trying to define using this shaded thing, we are just describing it, we have not given it a name, we can give it a name as we will see later. So, this individual here, since it is related to two elements and both of them are from the class C, it belongs to the description for all R C. But if there was another individual here who was related to this one, but who was also related to this another one, then he would not fall in the class for all C essentially, for all R C essentially. An interesting point to note, which you should carry forward from first order logic, is that if there is an individual who is not related to anyone, then that individual also belongs to this class C. So, as we said in logic, it is vacuously true. The other kind of relation we can talk about is existential restriction, that there exists, and there is a word that we use, at least one member from the concept C. So, if you look at the same class that I was trying to define earlier, the same set of individuals that I was trying to define earlier. So, this was C, there was one individual, let me see, one individual here, one individual here and a third individual here. This one had two elements connected to here, this one had one element connected to the one here and one outside this class C. Now, this concept says, we are trying to define another concept, is that whose role is filled with at least one member from the concept C. So, as you can see, of the three individuals that we were talking about, only these two will form the concept, will fall in the concept that we are defining now. That they not only do they have to have a role filler from C, they have to have a role filler to start with essentially. So, there must be at least one person they are related to by this role filler essentially. So, for example, people who have a daughter, there must be at least one child who is a daughter. This next concept talks about a self loop. It is basically the set of all those individuals in which the arrow points back to themselves, whatever the relation is. So, for example, you can say the set of all those people who love themselves, which hopefully will be as large as possible, because it is a healthy thing to do, but we could define such sets here essentially. So, formally speaking, there is a pair A, it belongs to the image of the role. So, we had kind of omitted talking about this. For the existential relation, we are saying that it is a set of all those people from the domain such that there exists a B such that A B belongs to R and B belongs to the class C. For the other relation, for all role fillers C, again it is a set of people from the domain such that for all those elements B where A B belongs to R, B must come from the set C. So, logically this is how you would express them. Then min cardinality, at least n role fillers from class C, that is what we are saying here. So, the same example if I take that I drew some time ago, this person was related to this person was related to one element here and one element outside, and there was a third person who was not related to anyone. Now, if we were to say that greater than or equal to 2 R C, that means you should be related to at least 2 people who come from class C, then this is the only one which would fall in that concept. The other two would not fall in this concept. If I were to change it to max cardinality, that at most n role fillers, then for the same diagram, this is C, this is this element, this is this element. So, what are we saying here? Let us say it is 2 R C less than or equal to 2 R C, there are at most 2 role fillers which come from class C. Then again you will see that this is the same as what we earlier said was there exists at least one role filler. In this case there are 2, logically speaking it is a collection of all those elements from the domain such that the cardinality of this set, what is this set? This set is the set of all B's such that A B is related, A is related to B, that means they come from the role R, and B belongs to C is at most n. The cardinality of that set is at most n. So, both these elements that we saw fall into that. The definition for min cardinality was similar, the same set, but here the cardinality was at least n. The set of named objects. So, we have some objects A 1 up to A k, and then we simply say that these objects form a concept. So, for example, days of a week essentially. So, you can say Sunday, Tuesday, Wednesday, Thursday, Friday, Saturday form the day of a week essentially. So, that is the last of the ways that we can define concepts. What we will do next is to see how to define new roles and there are essentially a few ways of doing that. So, we are interested in defining new roles from existing roles via either role inverse or role composition. So, if we have a role P which comes from the set of named roles, Then we can talk about three kinds of rules. One is the universal rule, we will see this, the role itself or the inverse of a rule essentially. So, let us look at them one by one. U denotes the universal rule. So, it is basically every element connected to every other element in this thing. It is like a cross product of the domain. P is a role name, named role, and it is a subset of the domain. P inverse is the inverse of P, which says it is a set of all those B A's such that A B belongs to P. Or it is simpler to say the parent child relationship essentially. For every parent who is related to a child, there is a child relation to parent. So, role constructors are of two kinds as we saw. The simpler kind simply takes two roles and connects them. So, if you have an A here and it is related by a role to B, let us say aunt, and B is related to C, let us say cousin, then we are defining a new role which is like this. We can think of saying as your aunt's cousin essentially. So, it is a set of, well, I should really use consistent notation here. So, this is B, because we are trying to define this new role A to B, and what we are saying is that there exists an X such that X is the role filler for the first role. So, this must be X, and X is the in the domain of the second role essentially. So, A x belongs to role 1 and x b belongs to role 2. We can extend this idea to a whole chain of roles, and I think we in India are very familiar with this, that my sisters, father-in-laws, brothers, niece. So, you can have a whole chain of relatives essentially, and that can be done by saying that you are a chain of roles essentially. The idea is still the same, that you are trying to define a role A to B. So, A is here, B is here, and there exist all these x 1 up to x k minus 1 such that A is related to x 1 and x 1 is related to x 2 and so on eventually till B essentially. So, x k minus 1 is related to B. So, we can have a role chain. So, essentially this is a description of a complex role in some sense. We have not given it a name, but we can always give it a name. So, we will come to concept axioms in the next session.